أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. I welcome you all to the channel today. In today's video we will solve problems related to projectile motion. In the first video we introduce the concept and we explain almost everything. In the second video we derive the relevant formulae we need for solving problems related to projectile motion. We also made mention of the fact that we may sometimes have to use the equations of motion under gravity, especially when the angle of projection is not given, or when it is horizontal projection or vertical projection. But for projection with angle between 0 and 90 degrees, such as angle 30 degrees, 45 degrees, 60 degrees, we need the general equations. Inshallah, today we will solve a few problems on projectile motion. Without any delay, let us see problem 1. Problem 1 says a football is kicked with a velocity of 5 meters per second. This is the velocity of projection, initial velocity of projection at an angle of 30 degrees to the horizontal. Calculate the time of flight, capital T, the maximum height, capital H, and the range, capital R. And in doing so, if you need G, then take G as 9.8 meters per second squared. Okay, let's start solution. We have to at first draw the clear picture of the situation. This is what we have. This is our y and this is our x. Now the particle was initially here and then it was projected in this direction with an initial velocity u as 5 meters per second, and then it makes angle the angle given here 30 degrees. It makes angle 30 degrees with the horizontal. Then the trajectory of the particle is here. This is the trajectory of the particle all the way to here. Now from here we see that we have a maximum height here. This is our maximum height, and then the greatest horizontal distance is our range, is here, capital R. This is our range. Okay, let's start solving them one by one. A says we should get the time of flight, and the time of flight from the equations we derive, we found out that the time of flight is t is equal to 2u sine theta divided by g. Now we continue and say this is 2 times our u is 5, so we have 5 times sine, the angle is 30 degrees, divided by our g is 10. Then we now take our calculator and press open bracket, close bracket. So you press open bracket, 2 times 5 times sine 30 degrees, then you close bracket and you now press divided by, we are taking 9.8 for G. We were asked to take 9.8, so we divide by 9.8, and this will give us 0.51, approximately 0.51 in second. This is the time taken to complete the motion. Now for B says we should get the maximum height, and the formula for maximum height, we derived that formula and it was H equals u squared sine squared theta divided by 2g. Moving on, this should be our u squared. U is 5 squared, sine squared theta, our theta is 30 degrees, so sine squared 30 degrees divided by 2 times 9.8. okay, this is equal to our 5 squared is 25. okay, then sine square theta means sine square 30 degrees means sine 30 degrees squared divided by 2 times 9.8. 2 times 9.8 will give you 19.6, so you have 19.6. This is equal to, then you now press 25 open bracket sine 30 close bracket, you now square it divided by 19.8, and you now press the equality sign. When you do that, the distance, the maximum height is 0.32 approximately in meters. 0.32 in meters. Can you see that? What you have here is 0.315, so you need to add 1 to this one because this is up to 5, so 0.32, you are rounding up. Finally, we are asked to get the range, and the range from the formula we derive, a capital R is u squared sine 2 theta divided by g. Don't forget, this is sine 2 theta and this is sine square theta. This has to be on top, and this means twice theta. So this is equal to, our u is 5 squared multiplied by sine 2 into our theta 30 degrees, then everything divided by g, and our g is 9.8. So this is equal to our 5 squared. Our 5 squared is 25. 25, then 2 times 30 is 60, so we have sine 60 degrees divided by 9.8. Next, we take our calculator and press 25 sine 60 degrees divided by 9.8. When we do that, clearly our result will be 2.21 in meters again. Okay, so the time of flight 0.51 seconds we got, and then the maximum height 0.32 meters, and then range is 2.21 meters. Okay, in case you have not memorized all these formulae for the time of flight, maximum height, and the range, you can also use the equations of motion under gravity, okay, and you will arrive at the same result. So let me show you how you can do that. So we are going to write here O, meaning you can also solve this in another way. If we draw this again, we need to draw it again. Now this is our y and this is our x. So our particle is projected with an initial velocity of u is equal to 5 in meters per second. Then this has a component along here. We can bring it here, okay, its component along here, and its component along vertical is u sub y. We know that, u sub y, and this u sub y is u, it makes angle theta here. The angle is 30 degrees as given, so this is u sine theta, and this is u, our u is 5 sine 30 degrees. So you will now press 5 sine 30 degrees. This will give us 2.5. So our vertical velocity is 2.5 in meters per second. Then it also has horizontal component of the velocity along here, okay, along here, and this is u sub x. It is u sub x, and our u sub x is u cos theta, and this is our u5 cos our angle 30 degrees. So if we now take our calculator and press 5 cos 30, we will get 4.33. So this is 4.33 in meters per second. So we know the vertical component of the velocity. We also know the horizontal component of the velocity. Now let us draw our trajectory. You see, this is our trajectory, and then we have the maximum height here. This is our maximum height, and then we know our greatest horizontal distance is our range. We know our range here. Okay, the first problem says we should get our time of flight, the time taken to move from here to here. So we are going to use a formula for the vertical displacement. We say that at any point A, let me write this A, at any point the vertical displacement is given by y is equal to u sub yt minus half gt squared. Now at this point, when the journey has ended, your y is 0. There is no vertical displacement because it is already on the ground. Okay, so it means at that point your y is 0, so you substitute 0 for y, and your u sub y, you got your u sub y as 2.5, so this is 2.5. And then your t becomes time of flight, capital T, because the journey has ended, so time at this point is capital T. Then minus half half g, and then capital T squared. So from here I can divide both sides, each term here by t, to cancel one of the t's here, divided by t, divided by t, divided by t. So 0 divided by t is 0, is equal to, then this one t cancel t, and I have 2.5. Then minus this will cancel one of the t, and I have 1 over 2 g capital T. Then I can multiply I can now multiply each term by 2. So 0 times 2 is 0, is equal to 2.5 times 2, 2.5 times 2, and this will give me 5. So I have 5 is equal to, and then if I multiply this by 2, this 2 will be cancelled, so I have gt minus gt. So I will bring this one here. I have gt is equal to 5, so my t is equal to 5 divided by g, and this is 5 divided by my g is 9.8, and then I can now press 5 divided by 9.8, and this will give me 0.51 in second. You see, initially using the formula we got 0.1 second. You can see it here, 0.1 second, and then using this idea as well we got the same result. So for B says we should get the maximum height. Okay, remember at maximum height here the vertical component of the velocity is 0. So we will use this formula that says v sub y squared is equal to u sub y squared minus 2g, and our height is the maximum height. I remember the velocity, both final and initial, we use vertical because it is due to this vertical velocity that it is able to cover the vertical height here, which we call maximum height. So at maximum height, the velocity there, okay, taken as the final velocity, is 0. So this is equal to, then your u sub y is 2.5, so you put 2.5 here square minus 2gh. Now bring this one here, it will become positive, so you have 2gh is equal to 2.5 squared. Divide both sides by 2g now, this one by 2g, this one by 2g, this cancel this, and then your h is equal to 2.5 squared divided by 2g, and this is 2.5 squared divided by 2 times your g is 9.8, and when you multiply 2 by 9.8 you get 19.6. So this is equal to 2.5 squared divided by 19.6, and now press this 2.5 squared 2.5 squared divided by 19.8, and this will give you approximately, look at it here yourself, 0.32 approximately. So this is 0.32 in meters, because range maximum height is also distance, so it has to be measured in meters. Finally, how do we get our R? Remember, in the video for derivations, we say any horizontal distance is equal to the horizontal component of the velocity u sub x multiplied by time. Now, when this x is maximum, you get the range, capital R. This is the highest value of x you can get, and this is equal to this u sub x remains, but this time should be your time of flight, because when you have range, the journey is completed. So this is equal to your u sub x is 4.33. Now we are solving for C, 4.33 in meters per second, and your time of flight, you got that time from A, and it was 0.51. So we have here 0.51 in second, and per second cancel second, so we'll have it in meters. We now press 4.33 multiplied by 0.51, and this will give us, as you can see, 2.21, approximately 2.21. So this is equal to 2.21 in meters. So just as before, our range, you see our range, when we use the formula, we got 2.21, and when we use this idea again, we got 2.21. So you have a choice. If you like, you can use this one if it is easier for you to understand, or you can use the formula. In case you find it difficult to memorize the formula, please learn this one, resort to it, you will get the same result. Moving on, we have the next problem here with us. A very interesting one. It says that look at what it says. This is the second problem, and it says find the angle of projection at which the horizontal range, this horizontal range is the maximum horizontal distance, and then the maximum height is the maximum vertical distance. So we should find the angle such that when a projectile is launched at that particular angle with respect to the horizontal, the range and the maximum height will be equal. They will be identical, meaning if horizontal range is 50 meters, then maximum height is also 50 meters as well. So how do we solve this? Let us write solution and begin. Now, we need the formula for the horizontal range. Remember, we derived that formula, and we said that this horizontal range, capital R, is equal to range, capital R, is equal to u squared sine 2 theta divided by g, and we are going to call this equation 1. Then the maximum height, the formula for maximum height is h is equal to u squared sine square theta divided by 2g, and this is our equation 2. Now if they are identical, it means that R, we can it implies that this R is equal to H. So we can substitute the right hand side. We go to equation 1 and take this for R. So we have u squared sine 2 theta divided by g is equal to, then we go to equation 2 and take the right hand side for H, and it is u squared sine square theta divided by 2g. Now comparing the two expressions, if I divide both sides by u square cancel. Now if I can multiply both sides by g, the g here cancel, the g here cancel. So on this side, on the left hand side, I am left with sine 2 theta is equal to, on the right hand side, I am left with sine square theta divided by 2. Okay, moving on. How do I simplify the left hand side? this sine 2 theta that you see here, there is another expression equivalent to it, and it is 2 sine theta cos theta from trigonometric identity, and this is equal to, so we split 2 sine theta, sine 2 theta into 2 sine theta cos theta, and this is equal to sine square theta over 2. Now one may ask, how did we get this? Let me show you elsewhere. You see, in mathematics, there is what they call compound angle. If you have sine into a plus b, where a and b are both angles, they say this is equal to sine a cos b plus cos a sine b. Now here is this. If this b is a, now a plus a becomes 2a, so you have sine 2a is equal to sine a cos b becomes a, so a again, plus cos a sine, also here b becomes a, so put a. When you do that, this one and this one are identical, so you can just take one and double it, so you have sine 2a is equal to 2 sine a cos a. Okay, here is this. If this a is theta, then you have sine 2 theta is equal to 2 sine theta cos theta. Can you see that? So initially we had sine 2 theta, so we can split it into 2 sine theta cos theta according to this principle. This is why from here sine 2 theta that you see here, we splitted it into 2 sine theta cos theta. That's how we got that. Then we can now multiply both sides by 2 to cancel fraction. So this side should be multiplied by 2, this one 2 by 2, and here 2 times 2 will give us 4 sine theta cos theta is equal to the on the other side, this 2 will cancel this 2, and you have sine square theta. Remember, sine square theta means sine theta square, so I can write it as sine theta multiplied by another sine theta. This will give you sine square theta. Now as it is like this, you can see that I can divide both sides by sine theta cos theta, and then here sine theta cos theta. When I do that, clearly here sine theta cos theta vanish, and then I have 4 on this side is equal to then here sine theta cancel sine theta, so I am left with sine theta cos theta. Look at it here, and this one, according to mathematics, according to trigonometry, there is an identity that says a trigonometric identity that says tan theta is equal to sine theta cos theta. So now that I have sine theta cos theta, I can use tan theta instead. So on the right hand side, this cancel this. I have sine theta divided by cos theta, so it's equivalent to tan theta from that trigonometric identity. Now I can get my theta and say my theta is tan inverse of 4. So I press my calculator. To get tan inverse of 4, you press shift first, okay, this one, shift, and now you press tan, and then you press 4, then you press equality sign, and then this, your answer will be approximately correct to the nearest degree. You will get 76 degree because this is 75.96 something, so approximately 76 degrees. So whenever we project, and there is no exception here, this one does not depend on the velocity, the initial velocity with which the particle is projected, neither does it depend on the angle of projection at any neither does it depend on the value of g, that is where it is launched. Okay, it does not depend on the initial velocity. Whenever you project a projectile, whenever you launch it with an angle of 76 degrees approximately, then your range and your maximum height will be identical. Okay, with this we have successfully solved problem 2, inshallah. Now let us move on to problem 3. Okay, problem 3 here says a footballer kicks a ball at an angle of 45 degrees with the horizontal, or to the horizontal. If the ball was in the air for 10 seconds. Okay, this statement is another statement for the time of flight. They say that if they say the ball was in the air for 10 seconds, that's the time of flight. So it means your capital T is 10 seconds. Determine its initial velocity. So here you don't even have to draw anything. Your theta, your angle of projection, is 45 degrees. Okay, for solution. Then the ball was in the air for how long? For 10 seconds. So it means the time of flight is 10 seconds. 10 seconds. Now, what is the initial velocity? This initial velocity, u, is your target variable. They are not asking for the vertical component of the velocity, u sub x, u sub y, or the horizontal u sub x, but they said initial speed. It means this one, the speed with which it was launched. So how do we get that? Since time of flight is given, you use the formula for time of flight, because in that formula you have u there. You see, sine theta divided by g. So from here you can get your u. How do I get my u? I make u the subject of the formula. And how do I make u the subject of the formula? I multiply both sides by g to cancel fraction. Now g times t will be gt is equal to g cancel g. Now I have 2u sine theta. Next, I will divide both sides by 2 sine theta. 2 sine theta. The purpose is that I want 2 to cancel 2 here, sine theta to cancel sine theta here, so that I have only u on one side, and on the other side I have gt divided by 2 sine theta. Now I can continue and substitute the values I have. My g is 9.8 multiplied by my t is given as 10 seconds divided by 2 sine, the angle I am given is 45 degrees angle. So when I do that, okay, 9.8 times 10 will just be 98 divided by 2 sine 45 degrees, So I will now take my calculator and say, okay, 98 divided by 2 sine 45 degrees, and this will give me 69.3, approximately 69.3 in meters per second. So this is the initial velocity with which it was projected. With this one, we have successfully solved problem 3. Now we move on to the next one, which is problem 4. If you look at problem 4, I love this problem 4. Problem 4 said an Air Force pilot is flying horizontally at a speed of 300 meters per second, 3000 meters per second, and drops a bomb which hit the target 10 seconds later. You see, when he drops the bomb was in air. 10 seconds later, it hit the target. So it means this time should be the time of flight, because when it hit the target, it is on the ground, it has completed the journey. So the whole time it has taken in air was 10 seconds. So that is your time of flight. Now, at what height does at what height was the pilot flying? So what we are going to do here is that let us write solution here. Then what we are going to do is that let us assume that this is where the bomb is, and then since the bomb and the pilot okay, and the plane were all moving with this velocity should be the speed or the velocity of our bomb. So at this point, you know, they say it is projected horizontally, so this velocity is a horizontal velocity and not a vertical one. So here horizontally you have u sub x, and this u sub x, this is our bomb here, and u sub x is 3000 meters per second. Okay, now let's say this is the ground level. This is the ground level. We have the ground level here. Now, if it is projected, it will now follow this path. Can you see that? All the way to here, and then it hits the target here. So it means our target is somewhere here. It hit the target, and this is its trajectory. Now, we know that there must be some vertical distance here. We are going to call this one y, and if we want to find it, we consider the vertical velocity. Remember, your initial vertical velocity u sub y at this point before it is released is 0, and at this point the vertical velocity is maximum, so we can have v sub y here is maximum, and then this one will continue. Remember, from the concept of projectile, we said that horizontal velocity remains the same till the end of the journey. So even along here at the end of the journey, your u sub x remains 3000 meters per second. It will not change, but this one will increase from 0 to its maximum value here, down here. Okay, now the question is, how do we find this vertical height? Now remember the formula I gave you. I said at any point the vertical displacement is given by u sub y t minus half gt squared, but since it is falling, it is not going up, this one should be positive. So this is equal to, now initially before it was released, you can see that the initial vertical velocity is 0, so the vertical velocity here is 0. Please do not use this one. You are going to find vertical. They ask you, look at the question, it says what height was the pilot height. So it's a vertical distance, and we are not using horizontal velocity for that. When you use u sub x here, it means you want to get this horizontal distance. That's the only time you need this u sub x. Okay, this one is 0. If this one is 0, then this term vanishes and your y becomes half gt squared. Now this is equal to half times, now they say take g as 10 meters per second squared, so we are taking this as 10 times your t, the time of flight, 10 seconds, so we have 10 squared, and this is equal to then we know that this half is 0.5, so we press 0.5 multiplied by 10 multiplied by 10 again squared, and this will give us 500. So we have 500 in meters. Clearly when we look at the options, A says 3,000 meters, B says 30 meters, C says 300 meters, and then this one says 500 meters. So D is the right option. D is clearly the right option. Okay, in order not to prolong the video, the next two examples we will have a video for that. We are going to stop here, inshallah. In the next video we will cover problem 5 and 6, inshallah. Assalamu alaikum wa rahmatullah.